From beautiful Baja Tustin, the international headquarters of the McNeil Film Studios.
It's Professor Mark McNeil.
And what is he doing today?
Teaching us about economic growth.
That's right, economic growth. Wait, who is this Vinnie Musk guy?
I think you're talking
What?
about economist Hayek.
Hayek? Frederick von Hayek? This is Frederick?
The very same.
Wow, hi Fred. Fred, I'm glad Fred is here with us today. It's an important topic that is relevant to Fred here. All right, economic growth. What is it? First of all, economic growth is a process that occurs over time continuously. It represents an increase in the capacity or potential of the economy to produce. It can be shown two ways. See this production possibilities frontier? If a production possibilities frontier shifts outward, that's economic growth. Is this economic growth if we start from point A and move to point B here? Is that economic growth? Wrong. It is not economic growth because it's not an increase in the capacity of the economy to produce. It is an increase in output, but not an increase in the capacity. The production possibilities frontier shows the capacity. So it's got to be a shift to be growth. And the second thing that we can show it as is a shift to the right in the long-run aggregate supply curve, because the location of long-run aggregate supply curve shows you the potential level of output at any given time. So if the potential or capacity increases, that's a shift to the right of long-run aggregate supply, and that's economic growth as well. Economic growth is expressed as a percent. So that is a rate. So it's a rate of change, and it is exponential, and the rule of 70 applies. I use 70. A lot of people call it the rule of 72, but apparently 70 is more accurate, according to Professor Richard Zucker, the esteemed mathematician at our lovely institution. So this rule of 70 says, if you take this constant, 70, and you divide it by the rate of growth of something expressed as a percent, not a decimal, then that will tell you the number of years that this thing will double, whatever it is. So if the rate of growth of something is 7% per year, you take 70 and divide it by 7, and you know that it will double in 10 years, because 70 divided by 10 is 7. If, however, the growth rate is 4, then you take 70 and divide it by 4, and I'm not sure I can think it that fast, but it's something like whatever. If the growth rate is 1%, it's 70 divided by 1, and it takes 70 years to double. So economic growth rates matter. The difference between a 3% and a 4% rate of growth is quite a few years. And just to frame this whole discussion, economic growth is really important for this country and maybe for the world in the coming years, and particularly for the United States, because we have a situation where the populace, the masses, have been promised many, many things. Education, retirement, food, housing, medical care, etc., that are very costly. And do they have an equally well thought out plan for how to finance these things? They don't. That's why we currently have a $21 trillion debt. And in the last 6 or 8 months, that debt increased from 20 to 21 in a year with the highest recorded tax levels in the history of the federal government. So how are they going to pay for this in the long run? And the answer is, the best way is if we grow out of it. If we can grow at 4% per year, 70 divided by 4 means that we can double in 18 years, 18 point something years. Well, if our current GDP is 18 trillion, in 18 years, if that's the correct number, then we could have a $36 trillion GDP, and $36 trillion is enough to buy us out of a good bit of those promises and reduce the impact of them. Anyway, it's a rate of change, it's exponential, the rule of 70 applies, and how we measure growth is a very big deal. You know, there are economic cycles. This is time and this is real GDP. So real GDP kind of goes up and down, and there's peaks and valleys. These are economic cycles. And so if you start measuring at this point and you end down here someplace, it's going to look like there's negative growth. Or alternatively, if you start from a place like this one and you end right there, you say, over this period, look how much growth there is. The economy is so successful. And these guys say, no, it's a catastrophe. It's easy to make bogus political arguments by picking the starting and stopping date that you're measuring the growth rate. So you always have to be as clear as you can about this. And in case you're curious, this dashed line here shows you the long-term rate of growth, and that's the most accurate measure of how much the economy is growing. Growth is one thing. Real GDP per capita is another. How do we get real GDP per capita? We take the real GDP in any given year and we divide it by the population. And that tells you each person in that country's share of GDP. So how would we figure out the growth rate of real GDP per capita? And the answer is you would take the rate of growth of GDP and you would subtract the population growth rate. So that if, for instance, you have an economy that's growing at 4%, but the population is growing at 2%, then it means that each individual's increase, after you consider the population, is 2% growth per capita. Now, if you are like, and how long would it take for the GDP per capita to double if the real GDP per capita growth rate is 2%? Well, you take 70 and you divide it by 2, and in 35 years, the real GDP per capita will double. But what if you get your population growth rate down to 0.5%? Well, at 0.5%, that's the GDP growth rate minus the population growth rate, is 3.5%. Well, 70 divided by 3.5, I believe, is 20. In which case, real GDP per capita would only take 20 years to double, which is a very big difference. So the growth rate of GDP per capita matters a great deal. All right. In order to talk more about growth, I have to talk about the production function. The production function is a relationship between output, that's GDP, and the labor inputs. So it's a relationship between outputs and inputs. More inputs, more outputs. So we're going to draw this assuming that labor is our independent variable. Our dependent variable is real GDP. And everything else is held constant. What is held constant? The quantity of other resources besides labor, like capital and natural resources, those are constant. Technology is assumed to be constant, and the rules of the game, that's the most important part of growth, the rules of the game are assumed to be constant. So our variable is the quantity of labor, independent variable. Our dependent variable is real GDP, assuming that we have a certain amount of capital, a certain amount of natural resources, a certain technology that doesn't change while we're talking about this, and the rules of the game don't change. So that's the production function. I'll do more. But I think I've worked hard enough. I think it's time for a little coffee break here. I'll be back. Hold tight.
Professor, it's rolling.
Oh, excuse me. Excuse me, I was just doing an in-depth academic review of the Scottish cultural history. Yes, back to the law of diminishing returns here. There is a video in this series that spends more time on it. I'm just going to do a refresher here for all you people. the idea is that we have a fixed factor. In this case, we'll make capital the fixed factor, and the raw materials and the technology. These are all fixed. But we have like 12 machines in here, so that's the fixed factor. And what happens when you add labor, additional units of labor to this fixed factor? And the answer is, when you bring in the first worker to work with this capital, you get 10 units of output. So the marginal product, that is, the additional production that came because this first person came to work, was 10 units. Now, if this second worker comes in, the total output goes from 10 to 18. That means the marginal product of the second worker is now 8. So the marginal product of worker number 2 is 8. You add the third worker, and the total goes to 26. Well, we've got another 8 here. The fourth worker, the total goes to 30. So the marginal product of this fourth worker is 3. The marginal product of the fifth worker, we go from 30 to 32. So the marginal product is only 2. Boom, boom. And finally, the marginal product of the sixth worker is maybe 1, I don't know. And is it possible that if you add too many workers to this capital, that the marginal product could actually be negative, that the total product starts going down? Okay, so if we connect these dots, we end up with a production function that has this shape. Boom. And it's the slope that matters, because the slope is telling you how much additional output you get from each additional worker. And the law of diminishing returns says, as you add more of the variable resource to a fixed factor, the marginal product gets smaller and smaller. So that's the law of diminishing returns. And if the law of diminishing returns didn't exist or didn't work, then theoretically, every time you added another worker, you would get a constant increase in your output. So the first worker brings you 6, the second worker brings you an additional 6, the third an additional 6, etc. And you would have a production function that just goes up and up and up. And every time you get an additional worker, they just produce that additional amount of output. In this case, if there was no law of diminishing returns and these marginal product didn't get smaller and smaller as you had more workers, theoretically you could feed the world potatoes out of a plot of land this size. That all you would need to do if you wanted more potatoes was add more of the variable resources, add a worker. But at some point it's obvious that you would have so many workers on this little plot of land that they'd trample the crops and not produce more additional output. Anyway, the law of diminishing returns is widely agreed upon as a kind of a core concept. So what does this have to do with economic growth? Well, there is, if we take this production, we look at all of the output in the economy produced. So this is the aggregate production function. So given the constants, the capital stock in the country is what it is, the state of technology, the amount of natural resources, and the rules of the game are all fixed. What happens if we add 100,000 workers? Well, if we have no workers, we have no output. But if we add 100,000 workers to the existing capital stock and so forth, we end up with $3 trillion worth of output. If we add a second 100,000 workers, we end up with some additional amount of output. Say it's 7. Oh my, is this a problem? We don't have, the first batch was 3 and the second batch is 4. Oops, this is 7. So it's a marginal product of 4. 3 marginal product, second 100,000 gives us 4 marginal product. This is not diminishing returns, this is increasing returns. But at some point, will we encounter diminishing returns? If we had this third 100,000, all of a sudden now the marginal product is like 3, and then here the marginal product with these guys is 2, and there the marginal product is like 1, and if we take it far enough, the marginal product could turn negative. The idea is that as we add more of the variable resources, labor, to our fixed factor, the marginal product gets smaller and smaller. Well, this is very useful because it associates this amount of labor with this amount of GDP. This is real GDP on the vertical axis. So when we look at the economy as a whole, if we have the labor markets, the supply and the demand, and in equilibrium there are 400,000 workers working, then in the equilibrium quantity of labor, we plug it in. See these horizontal axes, quantity of labor, quantity of labor. If we plug 400,000 workers into this production function, the production function tells us that we will get $11 trillion worth of output, real GDP. And if there's $11 trillion worth of real GDP, whoops, let's make it 10, then when the labor markets are in equilibrium, given all our resources and technology and so forth, then our long-run aggregate supply curve will be at 10 trillion. Well, that's the basic model. The labor, the amount of labor markets are associated with the production function, and that combination of labor and the production function tells us how much we're going to produce. That's our natural level of output, or the potential level of output. Now, if we're going to make it move, that is, if we're going to do something with this model, there are only two possibilities. We can either change the value of the independent variable, which is labor. And you will recall that whenever you have a relationship between x and y here, for instance, if that's the relationship, if you change the value of x from 3 to 4, you get a movement along the existing graph. Whereas if you change any of the constants, that will give you a shift. So we're going to first change the value of the independent variable, which is labor. Well, how can this equilibrium amount of labor change? Well, what if, like in the 70s and 80s, the labor markets got the triple whammy? There were big increases in the labor pool because of baby boomers hitting the labor markets. Then the second was women coming into the workforce, labor force, in record numbers, and the third was immigration. So we got wham, 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 and the supply of labor increased dramatically in that period, and as a result, we had a new equilibrium quantity of labor, 5, and the real wage did go down a bit. But the quantity of labor is 5. When we plug the quantity, this additional quantity of labor into our production function, look what happens. Our real GDP goes up from 10 to, we'll say, maybe 12. And that causes our long-run aggregate supply curve to shift to the right. When our long-run aggregate supply curve shifts to the right, that's economic growth. So that's what happens when you change the value of the independent variable, which is labor. Then we plug more workers into the production function and look for the new output level from 10 to 12 here, and then redraw the long-run aggregate supply curve at its current level. Okay, that's what happens if you change the value of the independent variable. So here's the supply increase. The quantity of labor increases from 4 to 5 in this drawing, and when the quantity of labor increases from 4 to 5, the real GDP in this drawing, it goes from 10 to 10.5, and that shifts the long-run aggregate supply curve to the right. So when labor supply changes, there's a movement along the production possibilities, the production function, from this point to that point. What happens when we change a constant? There is a
Shift.
wake up, a what?
Shift.
Oh, thank you. Good job. If we change the natural resources, the capital stock, the technology, or the rules, if we increase these things, then our little game starts here. Because what each of these does is it allows the same amount of labor to produce more goods and services. If they have more natural resources, if they have more capital, if they have better technology, or if the rules improve, the same number of workers, 4 in this case, can now produce more than they would have before. Before the change in this constants, 400,000 workers would produce $10 trillion worth of goods and services. Now that something has happened that makes them more productive, then it goes from 10 to 12. And that causes the long-run aggregate supply curve to shift to the right. So that's economic growth as well. That's economic growth as well. And this will happen if any of these constants changes. The last little detail is a delightful little tidbit, and that is when this production function shifts upward, it's not just shifting upward, but it's getting steeper. I don't know if you can see that this part of the old production function is that steep, and the new part is steeper. So at any given point, at any given level of labor, this new last worker is more productive. The marginal product is higher because the technology is better or something. And it turns out that people are paid according to their productivity, and that the demand for labor is based on labor productivity. People are paid according to their productivity in the real world. Not in the teacher world, but in the real world. If you doubt this at all, just look at the productivity of your local NBA team. Whoever is the most productive in terms of selling tickets and bringing revenues to the team is the one that almost always is paid the highest amount, and the one who makes the least is almost always the one that is the least productive. So real wages and living standards depend on productivity, and productivity is the basis for the demand for labor. The demand for NBA basketball players has increased dramatically because people want it more, they're willing to pay more, which means their productivity has risen. And as a result, the demand for labor has shifted to the right a little bit because of the increase in productivity. And this little shift causes the wages to rise a little bit and causes the quantity of workers to increase a little bit. So when you do this, if there's a change in one of the constants, the production function shifting is the first step. Second step is use this amount of labor to figure out what is the new long-run aggregate supply. It'll show the economic growth. But then you have to come back here to the labor markets and show your little increase in demand that comes from the productivity increase. Wages will rise a little bit, and workers will, quantity of labor will increase. What kinds of things increase economic growth? What kind reduce economic growth? Is there a relationship between economic growth and individual freedom? And so, what increases economic growth? The biggest one is having good, reliable rules of the game. That's the most important thing. The second is having lots of good resources. So if you have an educated labor force, if you have lots of capital, if you have lots of natural resources, that helps as well. But the biggest one is having contracts enforced, property rights clarified and enforced, judicial system that works, reduce the corruption, that sort of thing. Obviously, corruption and high taxes and things like that reduce economic growth. What is the relationship between economic growth and personal freedom? Every year, first of all, the growth rates are all published by the various statistical groups. The World Bank is the biggest one. But also every year, there are a couple of freedom indexes published, and it just asks how free is the typical citizen in a country. And if you look at the highest to lowest GDP or GDP per capita, and then you look at the most free countries to the least free countries, it looks like the same list, but there's almost a one-to-one correlation. So you have some place like, I don't know, I think it's currently Switzerland that's at the top. Hong Kong's always been there, Singapore is always there at the top, and these are the highest GDP per capita. And at the bottom you get places like North Korea, Venezuela, those sorts of things, and those have the least growth. So that's it. That's economic growth. It's really important to you, to the world, to the future of the country. And the other thing that's delightful is that in order to be a successful, prosperous country, you have to provide substantial amounts of freedom. I think that's about it. Hasta la vista.